helps us on many topics around climate change. And I'll give you a few examples of what he has been doing in last 2, 3 years. And that should create a lot of interest, I'm sure, within you. And then I also have Rebecca with me. So as insurance or reinsurance company, we are in the business of paying claims. So she is the one who basically specializes in claims. So we wanted to give you the full spectrum. Someone on the science side, someone on the claim side, and I'll be doing more of talking. So with this, the agenda today is to tell you how industry perception is about climate change, because a lot has been written, a lot has been spoken, but it is very important for you to know that how industry is looking at it. And when I say how industry is looking at it, clearly in terms of the challenges which are being posed by climate change to different industries. And because we work as an insurer, as a reinsurer, so just for you who do not know this term, reinsurer, it simply means to insure an insurance company. So insurance company insures you all of us, and then there are companies who provide insurance to the insurance companies. So that is called reinsurance. So AXA, as insurance and reinsurance company, we are insuring many industries. And that is the reason we are at such a place where we get to see the impact of climate change across industries. So that's one advantage being an insurer or reinsurer being brings on the table. So when Gaurav and I, we were discussing that how should we present the industry view to all of you. So we thought, why not make renewable energy as a sector, because there is a lot of focus, as we know, on renewable energy, and a lot of investment is envisaged in next couple of decades. So as we say that by 2030, we want almost 50% of our installed capacity to come from renewable energy sources. And that's where solar and wind becomes quite important. And it was, in fact, intriguing for all of us, because when we were dealing with this industry in last few years, we saw that we observed that climate change is impacting this industry more than any other industry. And so it is counterintuitive. At one hand, we are seeing that as climate change adaptation, we are doing the energy transition from fossil fuel to renewable energy sector. And then renewable energy sector itself is getting challenged with climate change. So we thought this would be a very good example to show you that how climate change is impacting renewable energy sector. We will then show you that to adapt to that challenge, how we can design insurance programs and how climate science comes very handy for us. So the whole idea of today's talk is to tell you how important climate science is for the industry, and given the challenges which are posed by climate change, how you all can make contribution in the years to come. So with this, I invite Gaurav, who will be doing most of the talking. I'll be pitching in off and on. So Gaurav will take you through some specifics on renewable energy sector and how climate change is impacting it. Gaurav, over to you.
Thanks, Pankaj, and thanks for the introduction. I'll start with this one image that I have here. This is officially WMO confirmed temperatures for every day for all the years starting from 1940s. What we distinctly see here is 2023 starting from April or May, somewhere between April to May. Till the end of the year, it stands out all the temperature records, which means 7 months in a row were ranked record highest as far as this year of 2023 is concerned. I'm not denying, we're not denying, nobody among us is denying the impact of El Nino, that being the climate driver, and that being driving one of, a major fraction of these anomalies that we are seeing, the magnitude of rise of the temperature month on month for 2023. But for sure, the base forcing here is climate change. And that brings us to the second intriguing chart that I have. I'm very sorry it is not visible. So here I just wanted to talk about, if we talk about warming scenarios, we name a year that was the warmest on the record, it was 2023. If we name a day which was warmest on the record, it was 22nd July, like last week. There's a day which was warmest on the record. Obviously, it is these records, this 21st July and 22nd July will be further confirmed by WMO at the end of the year analysis when they'll analyze the satellite and ground-based in situ measurements of all the data sets that they have. But looks like it is credible. It has come from Copernicus and it'll rank as the record warmest day till such time that the Earth is existing. 22nd July becomes the warmest day, and 21st July again is the second warmest day. Then, if we rank these years in terms of warmth, we have 2023. 20, I mean, you start from 2014, go up to 2023. We have all the 10 listed here. So that's the point to start with. That climate change is very much here. We are seeing it. We are seeing it in terms of all the records that we are having. And then there was very important observation here that from the period of 1990, sorry, 2000, yes, this was 1997. So from the period of 1996 to 1998, there were episodes of one El Nino that lasted from 96 last to 97 last, and then very strong La Nina that lasted into 1998. So the temperature anomalies went up by almost zero point 0.5 degrees centigrades, and then they came down subsequently. Whereas the second event, El Nino event, that happened somewhere in 2015, that lasted into 2016, their temperature anomalies again went up by zero point 0.8 degrees, zero point 0.5 degrees centigrades, and then never came down. So baseline has shifted from 97, where we had an El Nino followed by a La Nina, and we were almost on the same baseline, and then gradually temperature was increasing. But 2015, what happened is this 0.5 degrees centigrades of warming was never recovered. So we have a base forcing in terms of climate change, and then we have climate drivers, El Nino, which needless to say, you all know that in fact is affected by climate change again. So everything, all the feedbacks combined, there was a jump of zero point 0.5 degrees centigrades that was never recovered. Then we are into 2023 again, where we have a warming of 0.45 degrees centigrades from normal. We are, a La Nina is being predicted, but we are not sure whether this scenario will recover from that warming of 0.45 degrees centigrades or not. So if it doesn't, we again have another precedent set where we have 0.5 degrees centigrade warming, and then that becomes natural and will count thereon. So that's the kind of situation that we are talking about. And that these are just some initial things to set up for you that climate change is very much here and it's happening. And then as an insurer, reinsurer, we also work for our industrial clients and corporate clients in order to stitch solutions for the resilience. And in that scenario, what we also do is to stitch insurance solution. We do some very niche branch of insurance called parametric insurance. We take weather and climatic events, parameterize them in terms of index, and then provide a solution to the corporate clients or groups. And that's a very niche branch, and that's unlike the traditional insurance that we have had. Doing that, I was analyzing the data set coming from the clients directly, their sites, wind speed data set and solar radiation data set. That data set had come to me from across the geographies of India, and time period was roughly ranging from that time period of 2005 to 2023, and it's hourly data set, actual wind mass data set, the actual wind speed recordings or the pyranometer reading recordings. What I had observed in that pursuit is that the wind speed is declining continuously, and we would see it in every geography that we analyze in India. Particularly, the wind farms are located along the west coast and southern parts of India. All the wind mass readings that I had analyzed, there was a peculiar drop in the wind speeds, and we were trying to understand why and how it is coming into the picture. And the same thing was happening for the solar radiation as well. So first take up this wind speed reduction, and we'll discuss the overall impact of climate change that might have occurred on these wind speeds being decreasing, particularly along the west coast of India. And then I'll come to the solar part. In that pursuit only, I had come across this important research article that was written for India, and it is titled as Secular Degrees of Wind Power Potential in India Associated with Warming of the Indian Ocean. First thing first, this is the capacity factors. Capacity factors in the simple terms, if you want to analyze, it is basically the feasibility or the location of the wind farms in India. These are the locations, the red ones and the yellow ones, as you see, and the, here on the bar chart. These are the locations where most of the wind farms are in India are located, because most of the wind capacity or wind speed, higher wind speed along the cycle of the year are higher, and which is why most of the wind farms are located in this region. So those are the red and the blue patches that you are seeing, and this is basically the variance of the annual wind speed. That does not matter much, but this is the foothills of Himalayas, where monsoon has much of a role to play during active and break phases. There is oscillation between the central India and the foothills of Himalaya, and which is why you will see the variance to be most in the part of southern parts of Himalaya, the foothills of Himalaya and northern part of India. And this part is mostly flat because the annual time scale variations are not as high in this region as compared to the northern part of India. That said, coming to the, yeah, now coming to the analysis of the trends of wind energy availability across India. They have simply considered one uniform power curve. Power curve is something which translates your wind speed to the energy. So such an analysis you'll have to do with certain kind of assumptions. What they have done is they have taken one uniform power curve, and they have taken actual mirror to wind speeds, hourly wind speeds, in order to derive this particular trend that you are seeing in India. As you had seen that most of the capacities or the wind farms located in this western parts and southern part of India, and that's where you would see the most potential decline in the wind speeds for the Indian region, particularly Maharashtra and Gujarat, where still we have lots of wind farms, lots of wind capacity installed. There is at least 4% decline in the wind energy potential, so to say, wind energy availability in this part of India, and which is actually huge, because when these IPP companies, when these wind farm owners have these yield assessment done, this 4% will come to 4% decrease will come to somewhere their decline of annual energy production to from P50 to P75 levels. And that's actually very, in a magnitude, that's actually very huge drop that we are talking about. Similar is the story for Maharashtra, Karnataka, Tamil Nadu, and some locations in this part of India where we have some wind farms, not so many. There's a consistent decline that you would see across the parts where we have most of the capacities in the form of wind resource availability that we have. And these are the listed values for these states of Maharashtra, Gujarat, Rajasthan and Karnataka. These are the quantitative numbers, but qualitative
is based on
yeah,
actual observation or analysis.
reanalysis,
Yeah.
mirror. These are based on the mirror to data set, sir.
No?
Mirror to data set.
Okay.
Yeah.
Now, how we know it good?
A mirror to data set, as far as I have seen, and I have seen more than 200 wind farms in India. The correlation with the hourly wind speed never drops below 96 to 97%.
Okay.
We have 2020, year of 2020, July, and this is listed across the articles in the media. You'll just search for this wind energy 2020 July. He'll say that more than 40% drop in the wind energy availability in India, particularly July 20. That particular peak is seen in across the data set, as well as this mirror to data set that I have analyzed. Similar are the cases for other months, other years. And when we do this analysis, correlation analysis, regression analysis, all sort of this comparison analysis, this stands out that this mirror to data set, however, is able to capture most of the variability on the interannual as well as intra-annual basis. So that's where instills in some kind of confidence the data set that we are analyzing, and we are actually taking this mirror to data set, or for that matter, ERA5 data set, for whatever height it is available. We are also taking that data set to structure a insurance cover. So we'll have to be very, very sure in terms of all the understanding of that data set, and which is why we dig in very, very deep into that and we found that data set is not as bad. It is able to capture all the intra and inter variations per se.
Can you look at the data also to see whether this is about?
Yeah, so with so this particular trend comes out good with ERA 5 dataset. The problem with ERA 5 dataset is that they have dataset available at only two levels. One is at the 2 meter, another is 100 meters. So we don't have any reference in between. Whereas MERA 2 provides it at 50 meters and 10 meters, and then they have sigma coordinates values available terrain following at 76 levels in the vertical atmosphere, where we have much more data set to analyze in MERA 2. But 100 meters, if we take from ERA 5, it comes out to be 2, and that's where we have this solar analysis done based on the ERA 5 data set. And you'll see that.
This is the money already high.
Here, this is 100 meters.
10,
100 meters.
yeah.
Uh, the hub height depends, depending upon the wind turbine and the geography that we are in. Hub height depends. The mean will be around 100 meters, but it will be varying between. The least that I have seen is 78 meters. The highest I have seen is 135 meters hub height of the wind turbine. So that's my experience, and this is particularly the research paper. So, and then if we talk about the magnitude, and you all will know it that in India, spring and summer are the times when we have most of the winds available. And in those particular seasons, we'll see that this decline is highest, 0.28 to 0.3 petawatt hour per decade. And then the other two seasons, there is a decline, observed decline, but which is not as high as that observed in summer and spring. So these are the temporal and intra-annual characteristics that they have discussed in this paper. And then coming to the mechanism, and I'll not be digging very deep this particular topic. The crux of the matter here is that there's a warming of the Indian Ocean, and that warming is not uniform. Western side of Indian Ocean is getting warmer at a higher rate, whereas eastern side is not as much. So the gradient of the pressure between Indian landmass and the Arabian Sea side is basically decreasing. Then gradient of the pressure is decreasing, that is leading to weakening of the wind speeds over western parts of India. And that's what precisely they have analyzed in terms of gradient temperature difference in the equatorial Indian Ocean, western.
Well, but previous slide, I'm worried. Previous slide showing.
Yeah.
9-degree increase in pressure. That doesn't look right. I'm sorry, according I'm sorry, you're using different.
Yeah, that was scarce, yeah.
So tell me, in EIO and SIO, temperature increase in the last 10 years, 20 years?
This is in the range of 2 degrees. SIO is 1.4 degrees.
1.4 degrees.
Yeah, that's not, yeah. So,
What India is not changing.
not as much.
Huh?
Not as much. This is between the eastern equatorial Indian Ocean and the southern equatorial Indian Ocean.
This is mean, right?
Yeah, that's that. Yeah, temperature.
Okay.
But for Indian subcontinent, it is not changing as much as you point.
That's surprising because look at surface data,
Yeah.
India is also warming. Right?
Yeah. And this particular
100 meters is not warming.
Yeah. And this is not 100 meters, this surface temperature that we are talking about. This surface temperature that we are talking about. And then this particular part of India, if I would look at closely, this is the belt where warming is profound. And then the right to it, east side of it, the warming is not as profound. There are some places where, in fact, in the graded data set and reanalysis data set, both the places we see some degree of cooling, which is why it looks like this is flat. But this is not my analysis. This is directly taken from the paper that I have cited.
Now, I would like, if you kept the scale similar,
Yeah.
you see, I don't have picture. See, your right scale is 1.5.
Yeah.
Left scale is 20 degrees.
Yeah.
That's what causes confusion.
Yeah. No, for sure.
Use the same scale,
Yeah.
inch.
Yeah. So I did not, unfortunately, draw this particular curve, because I have directly taken that from that science advances paper. So yes, and then they have explained this particular mechanism using model experiments where they have warmed ununiformly the western side of the Indian Ocean, and then they have found that the pressure gradient is not as much, and due to that, there could be some significant decline in the wind speed. Now, the takeaway from this paper is that I was not very much convinced as you are reading this paper that this is the real mechanism for decline in the wind speeds over India. There could be something else that on the intra-decadal times, intra-annual time scale that needs to be further investigated. And that will bring out the real reason as to why these wind speeds have been decreasing. And this could be one of the potential research problems for some of you to have a look at it and then come up with a proper mechanism. This is the study which was done by most of the foreign authors, and this being such a prominent topic for research that if you want to write it, it gets published in the good journals as possible. So, and this is something that we have done at EXA Climate. This particular research. So, at the wind speed, we have also seen decline in the solar potential in India, solar radiation basically. And here, the reading is very simple. I have taken surface solar radiation downwards data set, ERA 5 directly, no analysis, simply plotted the significance of the trend and trend themselves for the period of 1979 to 2021. And as you would see that most of the parts of Western India, in this case, we don't have capacities only available in this part, but also in parts of Rajasthan, Gujarat, and everywhere. So here you would see that solar radiation is declining in the western parts of India, also parts of Arabian Sea, etc. of Western Ghats and all those regions. And this is one picture. And then we had come across because we were into this business of stitching insurance product for solar companies as well. And we'll show how this insurance product we are stitching today. Then we also happen to pay certain amount of big claims to solar farms where their annual aggregate solar radiation was not as much. That's what intrigued us, and we started delving deep into this particular problem. Sorry. Okay. These units are joules per meter square. So as I've said, I've not done any data massaging. This is joules per meter square per decade that you'll need. This is for the period of 1979 till 2020. So to further, investigate it, I just bifurcated it into the two distinct scenarios, just to get a sense that has this decline in the solar potential been uniform in this satellite era from 1979, or has there been some kind of regime shift that also needs to be looked for, because climate change has been most unprecedented in the recent times, as we have seen in the first two slides. So to do that, we have this first analysis done for 1979 to 2000 period, and you would see that most of the impact was in the parts of India towards northeast and northern, foothills of Himalaya and then extending into Bangladesh. And then comes the second part of this particular data set, the last 2 decades, and there you would see the impact has been most pronounced in the western parts of India, including parts of Gujarat. Rajasthan is not touched as much, but Gujarat and afterwards it is very strong decline. The dark blue region that you would see in terms of magnitude, just to give a sense out of it, it is almost 5 to 7% of the decline, the darkest blue that we are seeing. And this is solar radiation data set. Here, 3 or 4 points that we had in terms of 2021 Karnataka. Everybody knows here that 2020 and 2021 Karnataka, the monsoon extended into October and November. 2021 November was entirely rainy. There were so many rainy days, and that's when we paid a claim of 3 crore rupees. And that's being evident in this ERA 5 data set as well. So those are the 2 points where we backtrack, we check for the data set, how it is coming from the analysis sources, and we have some degree of confidence, though not exactly matching parameter readings sometimes, when compared with these hourly radiation values are not matching to that extent. But if we take the daily average and monthly average, they are to certain extent corroborating each other. So those data quality trust related issues will always be there, but whatever data set we have, the analysis data set we have, this is that we see a decline in the solar potential as well across Indian region. This becomes very, very important as Pankaj pointed out that 2070 we have the plan for zero, net zero, and before that we are doubling our capacity for both solar and wind. And there we are seeing that both of these renewable energy potentials are declining for India. Just to confirm, I have also done the real, EF analysis of the data set starting from 1979, monthly data set going into 2021 period. You would see the pattern, spatial pattern, also the principal component, which is corroborating our finding. The first component that we have drawn is corresponding to the trend in the data set. You would see that in the most recent period, the principal component magnitudes are higher, and that is blue. So it is basically corroborating the findings that we are seeing in the trend analysis. Also, further digging deeper into the sub-annual, seasonal scale, January to March, the impact is not as much. April to June to certain extent. This is only for the period of 2000 to 2021. But when it comes to the monsoon season, the impact has been most pronounced from July to September, the peak monsoon, both the peak monsoon months.
What period?
This is for 2000 to 2021.
Okay.
Yeah, the last period. The most pronounced impact you would see in the months of July to September, which captures our both the peak monsoon month of July. You would see this part is completely blue. The decline is of 5 to 7%, and that's what is reflecting in the overall analysis that we see. This partly is because of I have some evidences.
Not there.
Okay, in the October, November, December,
Yeah.
in North India.
I'm surprised, but maybe it is not as much as people thought it would be.
Perhaps, but
At least you can compare for the short period when Delhi had very high air pollution. It
Yeah.
must have gone down for that.
yeah, obviously, yeah.
Around Diwali.
Yeah, exactly.
But, this trend is not there.
Yeah. No, not COVID. I mean, it is overall, the AQI or the aerosol availability in India, and that's this reason. No, for sure, that's intriguing, and we'll try to investigate what happens on that local geographical scale of Haryana, Punjab, and Delhi, and so on. We'll for sure do that. We have some evidence in terms of what could be potentially happening in this region. We have not done the entire analysis. We have not analyzed the clauses. Sorry, this is not SSRD. This is my mistake. I have taken the cloud fraction data set, total cloud cover data set from the same era 5, and I've just plotted their trend. Its trend. It is a typo. I made this plot in the slide, so some mistake happened. And some evidence in the form of total cloudiness, that we see that cloudiness is increasing. That is intuitive because of lower tropospheric temperature increasing, surface temperature increasing, where air's moisture holding capacity is increasing, which will lead to more cloud fraction. But that's not as straightforward as I'm saying. So this requires further investigation. We are into doing the moisture budget analysis, also the Clausius-Clapeyron equation. And all those things we will do, but whatever little time I have found in my day-to-day.
This is also metadata, right?
This is also error data. Yes, sir. The same data.
Are they comparable? It's a big question because
Mera,
score is not easy parameter.
I completely agree. And Mera is something that I need to look at. ERA is something that I have looked at extensively across, across the region. This is not only India. For other parts of the world also, we have analyzed this data set, because we also have some connections to Australia in terms of wildfire activity, how it basically, the forecasting of it to certain extent for our understanding, also to analyzing in terms of overall wildfire potential. So this ERA 5 data set and all these variables that we are discussing becomes very important. So I've analyzed all those variables in this, various parts of the world. to some degree of confidence, I can say that they match with the ground-based observation, not to the very granular scale of hourly, as I told you, but daily to monthly and annual. They are roughly the same.
Yeah, this trend you're showing is mainly coming from monsoon season or whole year?
This is holy. This is holy.
Huh?
This is holy. This
This is
particular.
annual,
This is annual.
but major contributor comes from monsoon season.
Yeah. I have that map. Okay, I'll discuss it.
Okay.
This was done in a very quick manner. So yeah, just to have that sense, and then we have further analysis to be done in order to be able to have the confirmed evidences, physical mechanisms in terms of what has actually led to this decline in the solar potential availability. So that is the future course of action, and we'll do that analysis in coming days to come. So I would now request Pankaj to help us understand the insurance product that I'm talking about, also the role of climate science in terms of driving this cat modeling industry and other self.
Sure, I'm scared of the sticks. Okay, so this was science part of it. Now, we have to make a business case out of it. So I'll explain you how do we make a business case of what Gaurav has just explained to you. So what he has basically presented was our internal analysis, and then we have to validate it with various stakeholders. So what we do, we go to lenders who are funding these renewable energy projects. We go to investors like Brookfield, Blackstone. They are heavily invested in renewable energy sector in India. So we go to them to check that, okay, in last 10 years of your experience, how the generation has been. So what is your actual generation data? Is it at par with what your IPP presented you when they came to you for funding, or is it any different from them? And then we kind of revalidate our sort of observations or assumptions with them. So in last 2 years, we have been doing it with other stakeholders, not only with IPPs, but investors, but with lenders. And what we found that the lenders and investors are struggling, especially in last 5 to 7 years, to get the kind of generation they had envisaged. And that puts a big question mark for them whether to invest more in the years to come or not. And that's where we make a business case out of it. So they say that, okay, we are still interested in this renewable energy story, but we want a kind of hedge, a solution, if you can stitch something around it. So what we have then done, we have created an insurance product in such a way that we select the third party data set. Like, for example, if it is a wind power developer, so we say that, okay, we'll select a third party data set which is providing us the hourly wind speeds. And then we will agree with you that on an aggregate basis in 12 months, what should be the wind speeds for you to generate power. So what we agree, we agree two things with them. One, the third party data set from where we'll fetch these hourly wind speed values. Second, we also agree with them that how do we convert these wind speed values into energy generation. So for that, every turbine manufacturer, they come up with their own power curve that, okay, at this wind speed, we will generate this amount of power. So we agreed upfront with IPP. So with these two things, third element is that we say that, okay, you tell me your downside, that if you are not able to achieve X amount of generation, I'll pay you the PPA price for each unit drop of generation, which is solely coming from drop in wind speeds. So this is the insurance product which we have designed for them. So what we do at the end of 12 months, it's a product for 12 months. After 12 months, we simply extract the hourly wind speed from the agreed third-party data set. Then we convert those wind speeds into energy generation on hourly basis. And then we aggregate it up for the whole year. And then we say that, look, if it is below the agreed threshold, which we have agreed at the outset, if it is below that, I'll pay you. And I'll pay you exactly the same amount of PPA price which you have for each unit drop. So this is how we create business around it. And how do we price it is also very important, because there the experts like you will help us in pricing these products. So there are two elements which go to price these products. One is very simple, that we model historical data sets like last 40, 50 years data set to see how the wind speeds have been. Basically, they'll give us the kind of burn cost that, okay, in last 50 years, there have been 5 such years that you are not able to produce this amount of generation. That is one part. The second part where the climate science helps us, and that's where people like Gaurav helps us, that, okay, we are issuing a policy for 12 months. So in next 12 months, how do you think the climate drivers are going to impact my wind speeds? Like, for example, if we are into an El Nino year or a La Nina year, or we are into a transition year, for next 12 months, month on month, how do you see the wind speeds going to behave? So it's a kind of forecast which we take into account for 12 months with the experts like Gaurav, and that's where you all have to come up and make the difference in the industry. So these two elements then go in the pricing, and then we come up with that hedge price for the investor or lender to say that, okay, I will cover you, I'll hedge your energy production up to a certain threshold. And if you are not able to meet your anticipated production solely coming from the drop in wind speeds, we'll provide you the insurance cover. So that is how we are using climate science to mean business for us. And the idea of showing you this slide is that that's where we need people like you to help the industry in creating more and more such solutions. So renewable energy is just one example. We are creating such solutions for people like Uber, for example, in a particular area. If because of precipitation, their booking level may go down. So we are structuring covers for them that, okay, in this part of Bangalore on a particular day, if the rainfall exceeds beyond a certain threshold, I compensate you. Likewise, for a Pepsi or Coke, if the daily temperatures in northern India in the month of May or June, they are not as high as anticipated by them. So, okay, if they are not exceeding 44 degrees for a certain number of days in the month of May or June, we pay them claim for each such day, which is not exceeding the threshold. So covers like these where businesses, their supply chain, they are dependent on the variation in climate. We are trying to stitch solutions for them, and that's where you all are required by the industry to sort of come up with that climate science knowledge. Because people like me, we come from traditional insurance background, and traditional insurance industry works on the observed data, or we call it experiential pricing. So if, for example, the way I have been pricing a risk from last 20, 25 years, that if a factory in Bangalore, I check with them, how many times have you suffered a loss because of flood? Okay, I'll probably send one engineer to see what are the flood defenses which are there at the site, and I'll come up with a premium. Now things are changing, because now we have to see what can go wrong in next 12 months. Because in insurance industry, we work on a concept called return period, especially for these catastrophic events, flood, cyclone, etc. And I guess in last 40 years, we have never had problems with these return periods, which are prescribed to us by our partners. But only in last 5, 7, 10 years, all these return periods are going for toss, be it for flood, cyclone, and any other catastrophic peril. So maybe I'll spend only 5 minutes just to show you the kind of challenge we are facing as an industry. There is this, I'm sure many of you would already know what a CAT model is, but for those who are not yet exposed. So as an insurer, what do we do? When we insure one factory, for example, in Bangalore, I want to insure one factory. What do? I simply visit the factory, see how vulnerable the factory is to a particular peril, for example, flood. So I check what the flood defenses are. I check the past history of incident of floods, the losses they may have suffered in last 20, 30 years, and that is how I price it. So I don't need any model for pricing one particular risk. But the problem is that as an insurance company, I'll be writing at least 200 such factories in Bangalore. And there could be a possibility that in one flood event, all 200 may go for a toss. So for me, the aggregated loss, which can come to me in one event, maybe more than the capital I have as a company. So all insurance companies in India, you may have heard many names. In terms of capital, all of them have almost 200 to 300 crores. But imagine if 30 factories are destroyed in Bangalore, and I have insured all those 30 factories, the loss for me will be almost 100 times more than the capital I have. So I'll go bankrupt. So that's where this CAT model comes handy for me. So what a CAT model would do, so it is based on the historical observed data. So I have the data for last 40, 50 years that, okay, because of flood in this part of Bangalore, this has been the frequency of this kind of a flood. So for a particular magnitude, I know what has been the frequency in last 40 or 50 years. And then what this model will do, it will create some 10,000 event, simulations of 10,000 events or sometimes 100,000 events based on what kind of model I'm using. But there's a big problem now. With climate change, what is happening is that the both frequency and severity of these events is changing. So it is not what it was, say, a decade back. So then all the industry players, all the insurers and reinsurers, they came together, they formed a working group, and they agreed on one thing, that we need to adjust the frequency and severity in our CAT model. So that agreement is there, but the big question is that how do we adjust that? There is no one formula to do so. So they said that, okay, let's follow a particular approach. We'll take the observed data of last 40, 50 years, create the simulated events, say for 100,000 events, but then the results are counterintuitive. In the sense, if I have the observed data of last 40, 50 years, and in that observed data, most of the events are of shorter return period events. Then when I add these 100,000 events, majority of these events will get added to a shorter return period events. So the model output will show me as if the frequency of shorter return period is going to get increased because of climate change. And it is not as much impacting the higher return period events like 100 years or 200 years, which is counterintuitive because as the warming is increasing, the output should be reversed. So then we all were like, all the reinsurers were like, what to do with this problem. So, so all of us are trying many things. So like one particular reinsurer in our working group, they came with an idea that let's have two models. One model will have the simulated events, which are quite heavy for shorter return period. Let's have another model which will focus more or way more on higher return period events, and then we'll try to get a mean of that. And we will then feed this mean to a third model. So it is like you are averaging, you are first assuming two things and then you are coming up with the average. Not a correct answer. We don't have any solution. But why I'm highlighting it to all of you that the problems like this are in front of us, but we need the expertise of climate science to help us finding a solution. So, so this is what I wanted to show you. Maybe, yeah. So this is the curve which I have talked about. So this is called EP curve, which is an output from a climate model. So it simply tells us any point of the curve will tell us that for a certain probability, what can be the loss for you. And when we adjust the frequencies and severities, what we see that it does not address the tail of the curve. So higher return period events are not addressed by the model when I adjust the frequency and severity. So the whole idea of adjusting a model for climate change is going for a toss. So we do not have any solution, but a lot of research is being done by us, by some of our competitors like Swiss Re, Munich Re, but we are still figuring out what. Okay, so with this, the last part of our presentation, I request Gaurav to wrap it up in 10 minutes.
I'll not take your 10 minutes. So this is the, now we'll discuss the forecast and the validation of monsoon so far, 2024 monsoon so far. This IMD forecast that they released on 15th of April this year. They said that the probability of rainfall to be in the range of normal to above normal would be in the range of 90%, and that's too optimistic and too much. And then for all the regions, if you see Northwest India, Central India, South Peninsula, or even for the more, monsoon core zone, we have the probabilities ranging in the range of 80 to 90%. So which means IMD was very, very confident about this season being in the range of either normal, which is less likely, to be in the range of above normal to excess rainfall. And that's where the probabilities of the order of 16% had come from them. So let's see what happened this year. This is classical monsoon onset and progression map for 2024. Started around 31st May, 31st May in India. And then there was only one point in time when it was hanging around Gujarat and Maharashtra coast between 10 to 24th June. And after that, it quickly progressed and traverse the entire country in a shorter period or the climatological period of 38 days. It covered only 31 days, 32 days to be precise. So that's the monsoon onset and progression over India for 2024. This was an El Nino year, a strong one perhaps, 2023 El Nino. Many people have talked about it, and there are research papers already out about it. Just to contrast it with 2015 El Nino. And this time, I don't know what had happened, but monsoon was late to arrive in India. It was around 4th or 5th June that it arrived in India, completed the entire fetch in just 21 days. So these are the tale of two El Ninos. One, we have the monsoon to arrive at India and then progress over the entire country, taking almost the climatological order time. And here it just took 21 days, both strong El Nino events. Don't know what precisely the reason was for 2015, but that's anomalous. Then this is cumulative rainfall until yesterday. Sorry, 29th of July, day before yesterday. And this is the map that you see. There's some things which are not clear, but this is the excess rainfall zone. This is normal rainfall zone, and this is drought kind of a situation in India, below average rainfall zone. So you'll see in 2024 cumulative up to almost June and July, you have dipole pattern where north of India has received lesser rainfall, south of India has received excess of rainfall, whereas central India, the core monsoon, the rainfall has been of the climatological order. This is rainfall anomaly for the entire period starting from 1st June till 30th July. And the anomaly that you'll see that pattern distinctly. South and central India, they are either climatological levels or excess rainfall, whereas northern India. We don't know what's happening in Jammu and Kashmir, not much of a reliable data coming from the rain gauges there, but rest of the India, except for Northeast, this data set is at least reliable, the institute data set. So which means that there's some dipole kind of pattern where South India is receiving more than average rainfall and North India is not. Then comes only for the month of June, where almost entire India had not received as much rainfall, except for this patch in southeastern part of India and southern part of India, Tamil Nadu, Andhra Pradesh, Telangana, and so on, where there was good amount of rainfall that happened. But entire west coast and then central and northeastern part of India, which has not recovered as yet, also did not receive as much of a rainfall. And then comes July, where core monsoon zone fortunately had good amount of rainfall. So did the western part of India, coast, Gujarat, Maharashtra, Rajasthan, so on. But this, Uttar Pradesh, Bihar, West Bengal, all these eastern, northeastern, and northern part of India did not get as much of a rainfall, which is reflected in this dipole pattern that we have seen at the first place. The overall cycle, if we talk about until this period of 30th June, there was a total deficit of 10 to 20%. I don't exactly remember the number, but there was some deficit, and then there was a very strong episode of rainfall, which started early in July, lasted at least for 9 to 10 days, where the rainfall recovered very, very quickly, and we had almost 100% rainfall, seasonal, a seasonal rainfall for entire India. There was very small break period and then another active spell where it recovered, and now we are at 2.3% excess. Seems like there could be a break phase coming, but not sure. I mean, at least the forecast that we have seen so far says that there could be a break period of rainfall coming. We are not sure about it. We'll only know when it realizes. These are different parts of India. The most anomalous one here is east and northeast part of India, where we are at a deficit of 17.7%. Northwest India, where we are at a deficit of 16.3%. Both the regions had some point in time recovered the rainfall up to 100% or even more. But this last break phase that occurred here for a long period, starting from 10 July and continuing right now, did not come out to be very good for both the regions. They are at a deficit of almost to the tune of 20%, and then both other regions are Central India and South Peninsular India, as we have seen in the dipole pattern, are excess rainfall so far. And then to conclude everything here, I did not plot the sea surface temperature to compare. I plotted the equatorial heat content, upper ocean equatorial heat content from 80 to 150 west for the Pacific region, just to contrast these El Ninos among themselves. 2023, in terms of temperature anomalies, could not have been as much as 2015 or 97 either. 1982 anyway is much lower. But in terms of upper ocean heat content, it is only lower to it is only lower to 1997, and elsewhere when it had peaked, it was actually comparable or even higher with all the other recent strong El Ninos that we had seen. No, seeing purely analyzing the anomalies in the Pacific Ocean, not much of a evidence that it was a Central Pacific El Nino. It was a typical canonical El Nino, started right from the east coast of Peru and Chile, and then anomalies had progressed. However, towards the dying phase of it, the anomalies were more pronounced in the Central Pacific. And yeah, that's all from my side. If you have any questions, please ask.
My perspective, very different from what we now discussed. We discussed the rainfall. Now you see clouds, wind, on their road. So, are there any questions?
I was thinking that if you have any actual measurement of the speed, actual measurement
Yeah.
in the offshore and onshore, do you see the same decline, or that what you see in the mirror data, or?
Offshore, unfortunately, sir, we don't have. Onshore, we have. We have one in Andhra Pradesh, Rayalaseema and Anandpur. We have two farms, and we have data set for the entire year of 2023-24 and prior to that also. And we had seen those. In fact, we are carrying that list that ended on 30th of June, and we are analyzing that data set right now. And that corroborates with mirror.
Use. You can sell it better. So you are seeing, but I actually don't see any mechanistic calculation why it should be. It's really not convincing to me. So, I mean, at this point, I wouldn't believe this, because we really need to look at the more data set, and also look at we need real station measurements. And also, there should be a basis for, the same basis for, whether the clouds will increase. That's what.
Yeah.
So, I mean, it's very hard for me right now to really understand the basis for this.
Yeah, exactly.
It may be true or it may not. That's all.
Yeah, that's what we are also struggling with, to establish that for sure it has increased, and the radiations that we have seen in the parameter readings, as I have said, they have decreased, at least for the last 4-5 years, what we have seen, they have decreased. Cloud fraction, that's the this is the only source, and then unfortunately we don't have any measurements. So even if we remove this cloudiness part of it, the radiation part of it has come out in all the distinct data set. In fact, MERA2 and ERA5 are not the only sources. There are Meteonorm, there's Solar GIS. We have data source from those agencies as well, and they are largely based on Mera 2 or Era 5, so they would tell that same story, but they are also showing this decline.
In fact, we did actually look at, climate change, really big climate change for India. What we actually find is easterly anomaly in the southern peninsula. And in fact, westerly anomaly in northern, kind of, anti-cyclonic anomaly. So that would be actually very potential of increase in the north. And this is only monsoon season.
Yeah.
So yeah, actually, we probably more analysis. I mean, I think one straightforward thing would be just to at least see whether what I'm seeing is true. Yeah, use maybe, I don't know how many reanalysis products are there, maybe.
Not many.
And you should really put all of them in figure and see where is the mean and also what's the range, what's the data satisfaction.
In fact, I would agree with what you have just said, and which is why I have some analysis done on the wind speed. I chose to not present it deliberately, because in the concluding remarks only I said that this wind potential availability problem that has been already published in a very reputed journal need to be addressed. Somebody has to take some time out and see what has been presented in the paper, what has been outlined is actually happening on. What we are seeing in only based on some mass readings where we are concerned with. We are seeing some decline, but to establish it India-wide, and that to confirm the readings from that research paper, as I have said, it requires further amount of work.
Science advances. Right?
Yeah.
So is it very multiple data sets or?
No, it's just mirror to energy data set that way. Only one. And one model. Yeah.
So, how much do you say that you are using the analysis from the analysis data sets?
Sorry?
Like historical data sets, how much you are using to inform your teachers? In comparison with how much forecast products you are using? Are you using any forecast?
No, we are doing qualitative forecast all by ourselves. We are not using any forecast.
How would you use?
For say this year, if I have an assessment of the wind speed, next year I'll see what El Nino state is in, IOD state is in. Then I'll do the things that we do. I'll do composite, I'll do regressions, the overall impact of this. Climate drivers on the weather of that, or 12 months period, what happens to that particular variable that I'm interested in, say rainfall or wind speed. And by those mechanisms, I'll try to have some qualitative views. Then see the forecasts coming from various resources, NOAA or ECMWF or something, IRI, to have this, more granular forecast and more granular idea about the forecast, and to have some confidence in that. We fail sometimes, we succeed sometimes, but that's how.
Actually, I'll add on to it. So when we talk to corporate houses for business, we don't discuss the why aspect of it. That why wind speeds are going down, why solar radiations are going down, and they're not even interested in knowing why. This why is our internal cooking. This why is what we are deliberating with you. When we talk to them, we say that, do you validate from last 10 years generation data that you are not getting enough radiation or not? Yes or no? So, like for example, we did this with Tata Power for almost there 13 or 14
Yeah.
wind power plants across this western coast. And what we presented to them was not why what parts of climate science are responsible for it. When we present it to them, we make a business case out of it. That look, according to our research, your radiations at your plant should have been going down in the last 1 decade. Do you confirm that or not? With their own generation readings, they say that yes, it looks like the same. So can you give us an insurance product or not? So this why is our internal cooking,
Yeah.
and it is quite dynamic. I mean, probably in the years to come, we'll find out what they can expect then.
Question for you or Rebecca. Among all the underwritings you've done more in there for 2 decades now, which is the part which gives you hard pay in terms of payoff?
Which is the place.
No. Which industry is the one for climate change related instances
Peril.
damage that.
So for us, flood is one peril, which we say internally is very mysterious. So there is no solution yet. I mean, there are so many models. For flood, so many companies who claim that they have a superior model, better model than others. But so far, as insurers, I'm not talking about only India, but globally, for flood, we are still struggling. So whatever we anticipate in terms of our annual loss, which can come from flood for the entire portfolio, we don't get confidence at all. And that is one area which gives us most amount of losses. So flood is an extremely very first. And maybe one example I can repeat, which we were discussing during the lunch. So this recent Sikkim event, which was a glove event, it is talked about a lot in our industry because so in the policies, insurance policies which are issued to the customers, there is a condition which is imposed by insurer that if there is a loss or damage solely coming from glove, then we will not pay you full claim amount. We will limit it to a certain extent, maybe 100 crores, maybe 200 crores, irrespective of the fact whether your plant is worth 3,000 crores or 4,000 crores. So after what happened after this Sikkim event, the many clients, they started exploring taking the legal route. They said that, look, you are saying it is because of law, but during that period, we see there was excess rainfall situation. So was it only law? Or it was the case that multiple perils were operating at the same time, excess of rainfall, some geological factor, and then secondary peril could have been law. So how can you say that my loss or damage is due to law? So flood and the perils around flood, the primary as well as secondary, is a big challenge for us. It's a black box, to be very honest. And
And no models get it.
no model.
3 meter resolution, very costly model we have run. We tried to estimate depths. We did not get it. We are not able to still construct a product out of flood depth or extent. So what we have developed is that we take rainfall purely on purely the basis of this product. 5-day aggregate rainfall, 500 mm, we pay you claim.
And there are instances where we have failed miserably with this
Yeah.
approach. So our estimate
For friends, we got at least understand it. There is a lab, for example, let's say Calgary's and some predicted. So it takes about 30 days of rainfall, so that the site is fully saturated. So it takes about that kind of time, like 20 days of rain, so that the site is kind of fully water saturated. So any additional rain then starts kind of runoff, surface runoff. And so after, let's say, 20 days of, good rain, then you get, let's say, a 10 year that's 20 centimeters. That's when actually you see the downside. So for instance, even this July is long, yeah, we are again. So it was actually raining for a very long time. So really, after 20 days or something, you see, KRS coming up, I don't know whether that, I thought that information should be there in the models, something that are planned on, soil, basically soil conditions.
these are there, but the problem is that even if I design a cover in Mumbai,
So Mumbai is different because that's an urban area.
So, and I'm giving you an example because we get requests from everywhere, not only from some remote part in Sikkim or Uttarakhand. So in Mumbai, South Mumbai will behave very differently. In 5 hours, a certain amount of rainfall happens versus a Bandra. So, and a model is same. So we are.
So-
Because every city has completely different drainage.
Exactly.
outlet.
And then there are risks to the tune of thousands to millions. And we address all them in one treaty. It's very difficult. It's a difficult problem, which is where, the science, the climate scientists have to come together, make it better, and then we'll have some better sense of what it is going out to us. Yeah. Great. Yeah.
even Pradhan Mantri Fatal Bima Yojana, they are
Yeah.
incorporating that right now. So here you are giving PNRS data and you're taking, how is the index being calculated for a particular station? Is it based on a grade point data or you average a certain number?
If it is for a reason, it is for that reason. As we said, PMFBY, that's this program is RWBCIS, Regional Weather Provision Solution. So if that's for a reason, say Andhra Pradesh, we take Andhra Pradesh humidity, we take rainfall rate, and basis that we do it. If it is for one corporate client, one local farm, we want to ensure this particular forest against termites. Termites happen when we have 30% humidity, 100 mm rainfall in a day, I'm talking about, and 40 degrees temperature. These three combined become our index. This is that we parameterize it and stitch us.
That index, is it from closest grid point?
Yeah, it's closest. Yeah, it's closest. We have limitations. We always take it to the closest grid point because if we take it at the interpolated levels, there are certain assumptions that we don't want to get into. We take the data from third party, we provide the cover. We don't want to do any manipulations by ourselves because that's when we might enter into some arbitration with the client that we are dealing with. That you have interpolated it, you have to make some changes to the data set.
Yes, quick more.
Yes.
Do they also have the option of selecting an in-situ observation site if it is located?
No, because that will involve moral hazard. You have your farm, there you have the rain gauze and your own rain gauze. That's not being maintained by third party. Third party, which is auditable, which gives the data on API, which is QC checked every day and all those WMO parameters that third party is following. We are happy taking that data set. Yeah.
But why not, like Modus provides.
We take only for the cases where it is most useful. Modis, we take to provide cover for wildfire. Wildfire, we take Modis burnt pixel, basis that we give the payout. We take Sentinel, we take, all the satellites that are available, but that's available. But that depends which peril we are talking about, which geography and which particular gap, concerned area. Say it is wildfire, then it is Modis satellite, Sentinel satellite, and we calculate, we make that index. It is rainfall in India, we take IMD. So that, not that granular. I have that in my mind. I'll see that, but so far I have.
There are two questions online. Online examinations, okay, how you? Undergo. Move on.
Do I read it? So I'll have to. Okay, sure. Yeah.
Okay, yeah.
Okay, sure.
I'm not. Okay. Yeah, because I think Gaurav did a good job. He covered what happened in July. I'll discuss next week. So let's thank both Gaurav and Pankaj for a very nice presentation. Hope everyone gave a different viewpoint about how climate change will look like and what job process you have is very valid, not just about monsoon rainfall. Okay, thank you. And next week it will be another Srivastava. Srivastava will talk about. I will announce the topic on Tuesday. Thank you.
Yeah, so just as a token of appreciation, this is the first kind of a talk I think we've had. We've always had scientific talks. So thanks, Pankaj, for giving a perspective. We look forward to more of this. Yeah, so just a token of appreciation, please, all three of you. So Vinay tells me there's a water bottle to paint shelters when Delhi gets very hot. Thank you. Thank you.
Thank you.